All right, in this lesson, we are looking at 2.5, write that on the board, 2.5 complex numbers and roots. Okay. So instead of thinking them as complex, another word we sometimes use is imaginary. So before we get into doing our first problem, something we need to know, this is something you want to write down off to the side, is this thing called I. And I use a little italicized I. I equals the square root of -1. You need to write that down at the top of your paper, circle it a good 3 or 4 times. That's going to be super important, right? I equals, and that's called, I is the imaginary unit, okay? So I, the imaginary unit, is the square root of -1. Now we've previously talked about how it's imaginary because I cannot find the square root of a negative number. So let's look at the first two. I think you have 5 or 6 problems like these on your paper. I think it's 5. They're all pretty much the same, so we'll do these as my examples. First thing I'm going to do, I'm going to show the shortcut and long cut of this one. The long cut way would be to say, okay, this is the square root of -1 times the square root of +16. Okay, so because I have a -16 there, -16 is -1 times 16, so it's kind of broken apart like that. Well, if I break it apart like that, I can say, oh, there's 3. A second ago, I just said that the square root of -1 is I, so I'm going to replace that -1 with I, okay? And then, well, let's think about the square root of 16. Now, hopefully you know what the square root of 16 is, but if you don't, you can use our magic treehouse and say, okay, well, we'll multiply. 16 is an even number, so 2 times 8, 2 times 4, 2 times 2. I have a pair of 2s, another pair of 2s, one of each dice. I got 2 times 2, which is 4. So the square root of 16 is 4. So right now I have 3 times I times 4. Well, 3 times 4 is 12. So my answer is 12I. Over at number 2, that negative out front confuses people. I cannot cancel out my 2 negatives. So some people say, oh, I got 2 negatives, I just cancel out. Nope, doesn't work that way. I have a -1 out front. Okay, let's remember that, a -1 out front. Now, just like before, I know I can break it apart like I did right there. Remember I said shortcut? Shortcut is whenever I see a negative inside, I just know it's going to put an I out. And that's going to make that +75. Right? So now I can just worry about simplifying the square root of 75. So I'll come over here, we'll do our magic treehouse. All right, well, I know 75 is divisible by 5. Let's see here. Actually, nope. I'm gonna do this instead. 75. I'm gonna do 25 and 3. 75 is 3/4. And then 25 is 5 times 5. Break that one, broke that one. I have a pair of 5s, 1 dice. So up here I have -1. I have a 5, but notice this little 3 right here all by itself is still inside. So I end up with that right there. And then I can simplify that just a little bit more by saying, oh, well, -1 times 5, because I can multiply things that are outside. -1 times 5 is just -5. I still have the I, and then square root of 3. And as far as like order of writing them, that's what I usually do. Put the number outside first, then the I, then my square root. Okay, so that's what you're going to do on the first thing is 5 problems. Yeah. And then the next couple look like these. Now I'm going to skip ahead just because 6 and 7 are a little too easy. We'll skip to one of the harder ones. Just make sure I don't go too far. Yeah, perfect. All right, we'll do so it should be the very last one on your list. So this is number 13, okay? Now, I know I skipped quite a few, and that's because all the problems are like number 13. Actually, you know what was saying? I lied. Well, we'll do number 6. I'll do number 6 and number 13, even though number 6 is super easy. All right, so for number 6, it says to take solve by taking square roots. So all I gotta do is take the square root of both sides. Okay, the square root and squared cancel out, and I get x equals the square root of 9 is 3. But every time I take a square root, I have to put plus or minus. So my answer is plus or minus 3, or you could even write it x equals 3 and x equals -3. I don't usually write it like that. Usually I write it just plus or minus because it's quicker, but that's what it means. You have to put the plus or minus because notice that both of those numbers would work if I plugged them into the original. If I square 3 or if I square -3, they both give me 9. Okay, so there we go. There's number 6. Now I'm going to skip ahead to number 13. And I do that because once I start getting to number 8, and then 8 all the way down to 13, I'm going to start getting imaginary numbers. So let's see how we do 13. Well, I'm still just going to get x squared by itself. So step 1, let's add 3 to both sides. So I got 9x squared, those cancel out, equals -165 plus 3. That's going to give me -162. And then I need to divide both sides by 9. And so 162 divided by 9 is -18. Well, just like we did on number 6, I need to take the square root of both sides to get rid of that squared. Square root and the squared cancel out, so I get x equals, ooh, there's a negative right there. Well, I can make that I square root of 18. And then I think, well, can I simplify the square root of 18? Well, that's 2 and 9. And 9 is 3 and 3. So there's a pair. One dies. So I have x equals, there's a 3 that gets to go outside. And there's that lonely 2 inside. All right, so I have that, but I made a mistake. And I did not write the plus or minus, plus or minus, plus or minus. There we go. Now my answer is correct. All right, so problems 6 all the way through 13 are like that. Obviously, they get more steps as they go. That's why I skipped ahead to 13. It had the most steps in it. And then when we come to 14, it asked me to solve. Where's the answer? It asked me to solve by completing the square. All right, so let's see. How do I complete the square? So we're going to start by moving this constant to the other side. So I'm going to subtract 74. So I get m squared plus 16m, leave some space, equals -78. Okay. Well, if you remember, we had our rule yesterday of how we're going to fill in that space. And our rule was b divided by 2 squared. Well, here the b is 16. So 16 divided by 2 squared. Well, 16 divided by 2 is 8, and 8 squared is 64. So plus 64 here, plus 64 here. Right? And I know that this is a perfect square trinomial, so it's going to factor into a binomial squared. Well, what does it get? Well, this right here is my m. The sign is positive, and the square root of 64 is 8. And then what's that going to equal? It's going to equal negative 74 plus 64. Let's see here. That should be negative 14, I believe. Double check that. 78. Yep. All right. So now I need to get rid of that squared right there. What to get rid of a square? Square root. If I do it to one side, square root the other side. So I have m plus 8 equals the square root of negative 14. And I remember to put the plus or minus. I'm going to subtract the 8 from both sides. So that gives me m equals negative 8 plus or minus the square root of negative 14. And then now I can think, well, what negative 14? Can I simplify that? Well, because there's a negative, we'll make it positive by putting the I out front. But what about 14? Can I simplify that any? Well, I know 14 is 2 times 7, but 2 and 7 are both prime numbers, so I cannot simplify that any further. So the only thing I can do is say negative 8 plus or minus I square root of 14. Now, if that looks a little different from the answer I flashed up on the screen at the beginning, it's because I put just plus or minus, and they're going to do one of each. They're going to have negative 8 plus I squared of 14, and then they're going to have negative 8 minus I squared of 14. I like the plus or minus, so I can just keep them together. If the 14 was no, actually, no, never mind. I'll leave it like that. If I can simplify the square root of 14, I would, but I couldn't here. All right, and then the rest of those should be similar to number 14. So I should be able to finish your paper from that.